Hi, welcome to readmeproject.com.
The paper you have requested is bandwidth recycling in IEEE 802.16 networks. Let's see the introduction of our base paper. The worldwide interoperability of microwave access based on IEEE 802.16 standard is designed to facilitate service with high transmission rate for data and multimedia application in metropolitan areas. The physical and medium access control layers of Wimax have been specified in IEEE standard. Many advanced communication technologies such as octal frequency division, multiple access of TMA, and multiple input and output are embraced in the standards. Supported by these modern technologies, Wimax is able to provide large service coverage, high data rates, and QoS guaranteed service. Because of these features, Wimax is considered as a promising alternative for last mile broadband wireless access. In order to provide QoS guarantee service, the subscriber station is required to receive necessary bandwidth from the base station before any data transmission. In order to serve the variable bitrate applications, the subscriber station tends to keep the reversed bandwidth to maintain quality of service, guaranteed service. Thus, the amount of reserved bandwidth transmitted data may be more than the amount of transmitted data and may not be fully utilized all the times. The unused bandwidth in the current frame has no chance to be utilized in the form of data transmission. Let's have a look on our abstract. IEEE 802.16 standard was designed to support bandwidth demanding application with quality of services. Bandwidth is reserved for each application to ensure the quality of services. For variable bitrate VBR applications, however, it is difficult for subscriber station to predict the amount of incoming data. To ensure the quality of service, guaranteed service, the subscriber may receive more bandwidth than its demand. As a result, the reserved bandwidth may not be fully utilized all the time. In this paper, we propose a scheme named bandwidth recycling to recycle the unused bandwidth without changing the existing bandwidth reservation. The idea of the proposed scheme is to allow other subscriber stations to utilize the unused bandwidth when it is available. Thus, the system throughput can be improved while maintaining the same quality of service, guaranteed services. Improving the bandwidth utilization while maintaining the same QoS guaranteed service. Our research objective is twofold. The existing bandwidth reservation not change it to maintain the same QoS guaranteed service, and our research work focus on increasing the bandwidth utilization by utilizing the same unused bandwidth. The general concept behind our scheme is to follow other subscriber stations to utilize the unused bandwidth left by the current transmitting subscriber station. Since the unused bandwidth is not supported to occur regularly, this scheme allows subscriber station with a non-real-time application which have more flexibility of delay requirements to recycle the unused bandwidth. Consequently, the unused bandwidth in the current can be utilized. It is different from the bandwidth adjustment, in which the adjusted bandwidth is enforced as early as in the next coming frame. Moreover, this bandwidth is like to be released temporarily, and existing bandwidth reservation does not change.
Let's have a look on our flow diagram. Configure base station with subscriber station, then reserve bandwidth and then calculate memory. Then allocate bandwidth, check for bandwidth recycling. Then schedule bandwidth and allocate bandwidth. After that, transmit data through the reserved bandwidth. Stop the process. Let's see the demo of our project. First, we need to run base station.java in band recycle package. Go to subscriber communication, click start. Here we need to select start base station. The base station has been started now. Now go to substation and then substation.java, substation1.java and substation2.java. Here we need to give IP address of the base station. Click configure BS. This has been configured. Give it for all subscriber stations. Now base station is connected with subscriber station. Now go to subscriber communication and click process communication in base station. Then in subscriber station, click reserve bandwidth. It will show a message in base station. Click calculate memory and allocate bandwidth. The bandwidth has been allocated to each subscriber station. Now select file. Select any resources and click calculate bandwidth. Do it for all subscriber stations. It will have a message details received. Click transmission bandwidth and click complementary station. Now go to band recycle package, run const state to the Java. Give IP address of base station and click configure CS. Complementary station is connected with base station. Now click get scheduled bandwidth. Then go to complementary station. Here select any scheduling method. For example, I am selecting hybrid scheduling. Click bandwidth details and click blacklist. So it will show the blacklist users in the subscriber station. Then click hybrid schedule. The bandwidth has been allocated now. Now go to BS station. Here click allocate bandwidth. So bandwidth has been allocated to the blacklist users. Then here click transcript data, and in base station click receive data. The data is not received over. Thanks for watching clickmyproject.com.